Hello everyone, welcome to the video. In this video, we'll be doing an introduction to the blockchain. What is the blockchain? That's actually the, only place we can actually start with these videos just to get everyone on the same level of what it actually is. And so there are a lot of concepts related. You might have heard what Bitcoin, Ethereum, stuff like that. But at the very rudimentary level, the blockchain is a distributed ledger. So what does that mean? Firstly, it is distributed, so it is on multiple machines on the network. And so like Bitcoin and Ethereum, these are, there are multiple things. Bitcoin is a network. It is also a currency, and it's also a type of ledger. So, and there's probably more, and there's probably better ways to define these. I'm kind of giving you my interpretation. I'm kind of like learning everything, and I'm spitting out how I feel about it, or not feel, but how I interpret it. So just keep in mind, not the end-all, be-all. You can also learn more in other sources. But so let's start. It's a network, so it's a network of computers that are running software. And there are multiple types of nodes on that network. So a node is a computer on a network that is interconnected. So let's talk about the distributed ledger. A ledger is kind of like a history of events that happened in the past, or that happened. So the blockchain is a chain of blocks. So it's a append-only ledger, and in that block of change, what a block is a set of operations that are called transactions. So transactions are operations that send money to this person, like this account or this address sends this kind of currency to this other party. That's like a kind of transaction that can happen. There are multiple types of transactions, and essentially it's kind of like Git, where you have a bunch of commits, and if you know all those commits, all those deltas, you can arrive at a final state. Well, you can think about the blockchain that way as well. So in blocks, you have a bunch of transactions, and you have also other information that, the timestamp and kind of other housekeeping stuff. You also have the hash of the previous block. So like in programming, if you have an object and you can hash it with hashing functions, then you can grab the hash of the previous block and add it to the next block. Let's briefly discuss what hashing is and why it is used in the context of the blockchain. So hashing simply refers to passing data, so it can be binary data or whatever data, into a hashing function to obtain a hash, where the hash, from the hash you cannot retrieve what you passed into the hashing function. So that's one characteristic. It's destructive. So think about passwords. When you pass a password, so passwords use a specific kind of hashing, but essentially if you pass the same password, you only have to store the hash of the password and not the hash itself. So that makes it so you don't have to actually store the sensitive value, in this context being the password. You can only store the hash, and every time, and that uses salt. That's a completely different type of operation. But in the context of the blockchain, hashing is used to determine whether something has changed. So if the contents of the block has not changed, a same value passed into the hashing function will return the same hash. And so that is why the hash of the previous block is stored on the next block. Because if someone attempts to change the contents of a block, the hash value will change if it's passed into the same hashing function, and therefore you can detect that something has been corrupted. Now, there are instances where two keys can generate the same hash, and there are other ways to solve this problem. So normally there's like a backup mechanism to check whether the contexts are the same. But we're not going to go too much into depth into that. It's just to understand what hashing is and why it's used in the context of the blockchain. In order for everything to compute, you can't just like change the previous block. You have to change the previous block plus update the hash of the new block, and make sure that the new hash also works for the next block. So that's why it's I don't know if it's impossible, but it would be incredibly difficult to corrupt the blockchain. because you not only have to, you can't only edit one block. You would have to update all the hashes of all the other blocks perpetuum. And another reason why it's hard is because, like I said, those are what our blocks are. The blockchain is a sequence of blocks. It's a distributed ledger that's distributed across a bunch of computers on a network. And not only that, but you have to think about how does a block get added to the blockchain. And that's with consensus algorithms. So each computer network, you can think about it as a person around a table. They have to decide what the next block will be. And so the way it does this is with a consensus algorithm. So you might have heard these terms, proof of work, proof of stake, and stuff like that. And this is the reason why Bitcoin is so energy intensive, Bitcoin and Ethereum are so energy intensive, because the way it works, there are validator nodes on the network. And these validator nodes have to validate through, and I don't know exactly what the cryptographic problem is, but they essentially have to solve for one of the data points on each block that relates to the hash of all the operations, which is a very complicated operation to do. And that's why you have to have like specialized equipment like GPUs or I think they're called ASIC chips. Don't quote me on that. But yeah, a bunch of these networks, a bunch of these computers on the network are trying to figure out the next nonce for the next block. And the one who gets it correctly gets rewarded with native tokens. So in the context of Bitcoin, they'll get rewarded with Bitcoin, and in the context of Ethereum, they'll get a reward with Ether. Once a block gets selected, or once a nonce gets selected, the block can be added on the blockchain, and then it goes to the next block with a bunch of new transactions that happen at that time. So at a root level, that's what the blockchain is. So I'll just recap quickly. A block is a sequence of a bunch of transactions. The blockchain is a chain of a bunch of these transactions. They are linked together with the hash of the previous block. And that's why it's kind of difficult to kind of go in, and you can't really mutate a block without it being corrupted. And since it's a consensus on the network, all the computers have to be in sync. They all have to agree on what the current ledger is. It uses a consensus algorithm that will be specific to a network. So for example, both Bitcoin and Ethereum use proof of work, which requires validator nodes on a network to solve a problem, a mathematical problem, to get that nonce and put it on the block. Winners get rewarded with native tokens. And that's what crypto mining is actually the process of trying to determine what that data point is in the current block. So at a very root level, that's what the blockchain is. Now, of course, we haven't talked about why it's appealing in currencies like cryptocurrencies, why it's appealing in other decentralized applications. That will go into other videos because there's a lot of other things to add on top of this base kind of understanding what the blockchain is. But hopefully, you can kind of understand at a root level what the blockchain is when people talk about blockchain, because some people talk about cryptocurrencies and kind of mix the concepts of blockchain and cryptocurrencies, but they're not exactly the same thing. Cryptocurrencies exist in the context of blockchain, but blockchain itself, yes, it will have native tokens to reward network participants, but it is not the end-all be-all of the blockchain. So hopefully that kind of answers the introductory question of what the blockchain is. And I know it's not enough to have a full understanding, but in next videos we'll talk about why it's relevant, what are like other concepts like smart contracts, which actually add programmability on this distributed network, and other stuff like that. All right, so I hope you enjoyed the video. Thanks for watching. Let me know if you have anything to ask in the comments, like the video, and I'll see you in the next video. Peace!